Okay, my friends, today is my treatise on energetic reactions. Now, what are you looking at? Well, you are looking at energetic reactions. And what is this? That's red laser pulsed. That is accelerating red laser, which is nothing more than accelerating light. So light can accelerate, and you can see the particle that creates that wave, because it really owns a big region as it comes through. It's still only a tiny particle, and there it is, pulling away from itself because we have a Venturi here. And then we have what they call Higgs fields, which are high-speed electrons, which are photons, but they slam into electrons when they do this, and they create these Higgs fields because they are charged particles. They are not like photons that are neutral type particles. Now, that is smaller than light. You're seeing it, I'm seeing it. It came from a reverse spinning particle, which could be antimatter. I don't know. This is what photons look like. They have a bright spot and a dark spot, up and down. They got one this way and one that way. I believe these, that's an electron, that's an electron. Together, they create a photon. We have separated these. Not only that, we have separated the black from the whites. I will show that. This is the light as we can see it coming out of the Venturi, accelerated obviously, slowing down obviously, because you can see that it's coming slow. Well, you can see it's compressing. All right, now, and it's spinning to the right means it drifts to the left. So that is that. Now, let me show you about this, because what you are looking at all starts from a deal like this right here. All right? That is, it's a simple Bosch construction laser. It pulses red light. Now, of course, it's supposed to come back and see how far the thing is away. That's how it works. Well, we don't care about that part. We care about the pulse. When we see them pump, 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 you see a big ball of light coming out of there, but it's really only the spot in the center is so small you're never going to see it. But it controls what they call 21 centimeter line, which is a big region around it as it goes flying through the air. Everybody else got to get out of the way. And that's what we saw before. That's, well, I'll show you those again in a minute. But as it accelerates, it pulls away from its wave. It forces itself to compress all these particles into this restriction. It's called a Venturi. And they used it in the old cars, old carbureted cars, and it caused atomization, atoms, to going into the cylinders, and that made it so that it would explode and you'd have good combustion. Now, what we're seeing is the particles coming out the other side separated. So now they become polar, and they spin everybody that's around them, which is ether, and you see them do this. As they spin, they do this up above, right here. You see that? Those little dots all over the place there, surrounding these particles. The particles in the center, you can't even see it. But it's spinning so fast that all of the other negative particles around it have to get away so quick. They go pop, 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 pop. They're spinning like crazy. And I prove all these things. I can prove every single word I am saying with visual evidence, and it's all written up already. They just missed all of this, or they didn't really miss it all, but I'm not going to point any fingers today. I just want to get this, I want to get my treatise out there, and I want somebody to respond to it, but nobody's ever responded. And it's still, I'm saying all the same things, only I'm going to just put it into an extremely detailed, a presentation. Now, you saw what I have to present here. This is not nothing. This is serious. That's the pulse red laser. You can't see the particle, but it's right there. Then you can see the particle. Then you can see it accelerate. Then you can see it turn into plasma. Not only that, there is these things called neutrinos. Now let's look into that, because first of all, I am going to show you every single, 100%, 100% of electronic interactions, from heat to cold to light to lightning to electricity to static neutron, induce these neutrino shower interactions. The things that they say they can't see, I can show you very easily, as many times as you would like to see them. I am working with the particles that CERN is trying to find. They explode huge particles, thousands and thousands and thousands of times bigger than the particles I am working with. I am working with the tiniest particle that exists, and we have even found one smaller. This is light. This is not your big protons. When they smash their things, they search through piles and piles of debris. It's like going through an entire junkyard to find a spark plug. It's unbelievable. They should be working with light. I just don't understand it, man. Anyway, we're going to go a little deeper here because this is the truth. And they've dropped the Bohr model. All right, Bohr model was the standard model of electronic orbits and all that business. What was the core was made out of big protons and big neutrons and a tiny little electron. No, here's what it is actually made of, right here. This is electron flood theory. Because right now, I'm going to tell you right now, they know, they're 100% certain that the atomic model's wrong. I can show you a bunch of different videos. It just came out within the last couple of months. They've agreed. The atomic model is not right. It's never been right. They've always had problems, and they just never addressed them. Isotopes there's hundreds of different isotopes. They shouldn't exist because if a gigantic proton and a gigantic neutron are real, these isotopes cannot exist. Hydrogen has 9 of them. I mean, it's unbelievable that they allowed this theory to continue, this Bohr theory, knowing that it's just not right. But anyway, that's just the way things work now. So we are going to see electrons. We are going to see the separation of electron and gauge bosons. We've already seen the photons. 1837 of these electrons make a proton, which is, has a positive charge to it. 1838 make a neutron, which has a basically balanced neutral charge. Hydrogen and all atoms are cored like this. That's the core. And I'm going to show you, I'm going to build a core right on, I'm going to show you. In toys, I'm going to show you using toys. Vibration, magnetism, things that I can prove to you just by toys. I'll show you right now. Okay, my friends, this is Latham's Crazy Machines. Latham's Crazy Machines. Incredible tractor beam magnet. Watch. Here's what electron flooding is. You have the core of your nucleus. Right? So you got your nucleus, and then you got your electrons clouded around. Well, what happens in here? Right now, this is all positive, and that's all. Neutrons and positiveness, and all are just negative out here. Well, that's insanity, because the negatives would come crashing, but let's forget that. This is all electrons. Every one of these is an electron. They all fit together here until they hit a certain frequency, a certain number, really, is what it boils down to. And at that number, it stops. And then more of them try to come flooding in here, and they say, no, we got enough. You stay out of here. And they say, well, what do we want us to do? And they say, you stay out there. You're going to have a certain attraction and a certain repulsion, and you're going to stay right where that puts you. And that's called the S orbital, right close down here. And you can only have 2 guys down there. That's all. And then what if more guys come? Well, you put them up higher up. You see how many. You see where you put them 8, the next one, and then you just start spreading them around after that. They'll all find their way. And there's what they call a rule of 8. We're going to look into that. Now, what is he doing here? He's creating electron-flooded core. Let's just watch, because this is really cool. So he's got the more negativeness. Electrons have flooded the core, and that's what happens. The other electron, because here's what's going on. That's got a positive and a negative to it. That's not just a negative or just a positive. There is no such thing. That's got both, and it is pushed and pulled. All right, now watch. Now, right now, it's basically, just sort of hanging around, an electron hanging around with its atom. However, when heat comes along, when you start pushing electrons in, you start pushing that guy, more guys come into the sides, and all of a sudden he's shaking like this. That's called heat. And when he goes flying away, that's called light. All right, it stays pretty good. I mean, they attach well. Boom, that's light. Okay, you just saw heat. Well, you saw, first of all, you saw just what they call potential energy, where it's just sitting there, and the electron is just sitting there. Nobody's bothering him. Then you saw kinetic energy, which is heat shaking around. All right, the actual event of energy. And then you saw emission of photons, of electrons. Now, electrons will try to stay with another electron. That's their nature. There's two, they want to stay together with two, an up and a down. And I have some, I go along with some of the quarks, the up and down, and different bits of the theory, and we're going to go into that now. All right, now remember, I am working with electrons. I am working with light. When we shot light through that Venturi, it exploded. It turned into plasma. Well, what came out? Electron neutrinos. They were electrons. They spin that electron like crazy at a high speed, high voltage electron. Crashed into all of the particles that are in the air, that are extra electrons. You say, well, Roger, what are they? Well, why are they extra? That is what's called ether. Ether is extra electrons, and what they do is they attach to water molecules, primarily. Now, those water molecules are extremely polar, H2O. They want water they are extremely attractive to extra electrons. And extra electrons are ether. Case closed, they are everywhere. They are heat when they are forced in. They are cold when they leave. They are light when they escape from their substrate, from their matter. When they are accelerated through the Venturi, they crash into all of those electrons that are just sitting there in space. And they own these huge regions. They're, like I said, those are the potential energy. They're sitting there. They say, oh, don't, just leave me alone. I'm all right. I'm over here. All of a sudden, this guy comes through. He's got the same size like this. But boom! And what happens? You get that. Exactly what we saw. And why do we see all those dots surrounding the ones I showed? Because the particle itself is polar. It's got a positive and a negative end to it, and it's spinning like hell. And that's why you see all those dots. And I'm going to show you a 3D of that. All right, now watch. That's the electron showers. I don't see if you could see any difference from what those CERN pictures were. Now, you see all the little dots? Those are particles that were just existing in the air, and they're being agitated by the spinning particle that's in the center. You can't see that particle. It's so small, and it's just spinning like a drill bit. All right, it's not going. It's spinning like a drill bit. All right. It's not going flying here or flying there. It's got a positive and negative side to it, but it's just barely spinning. I mean, it's spinning like hell, but it's moving real fast. Now, what does that leave us here? Hold on uno momento. This is basically like 3D. Now, I don't know, Rod Warren did these pictures, and he did the experiments on this stuff, and man, I'll tell you, the pictures he came up with just blew me away. I worked with him for a year or more. Now, that right there, you see that dot? That's the particle. Right? Well, why is this like that? Why is this like this? Well, it's coming through the air. It's like a bullet. This is the fields that surround it sort of trailing off, just like a jet fighter coming through the air. Now, this one here, I've talked about this a number of times. I don't care. You have to listen again, because this is my treatise today. Now, I found out, I've done a lot of research on this, and I have suspected all these things prior to my actually seeing that they have done some research on this, and it confirms exactly what I'm saying. I am saying that the red, the blue, the green, those are different sized particles. They're not just the same particle. They're different sized particles. Now, are they two of these together is the green instead of one is the red and three is the blue? It could very well be. But I have seen, and I can show you pictures of the green and the red at the same time, and the green and the red show the same look. We're going to go through it in a minute. But this I find extremely interesting. All of these particles came through the accelerator. The same particles came from red laser. Now, it was red here. What I turned blue. That's because it's being crushed by these two. Somehow it pinched it in there. Well, when it pinched it, it forced it to exceed its red power. All right, so it's not a bigger particle at this point. It just seems to have more energy, because the blue is more energetic than red. It goes from red to green to blue. And then you go into your hard stuff, your ultraviolets and all that, up to where it really hurts your X-rays. And those are just bigger particles. That's all it is, bigger particles. Now, you can see that it sort of stops here. And then this one squirted out of here like a cork. And then you can see it appears to be it's going to come back to its redness. It's almost identical back to here. It goes from here to the violet and so forth. And it looks like it's coming back to what it was before. So the particle is the right, they're all the same particle. However, you can make that particle exceed the red energy by doing this. Now, way back there where we're coming out of the Venturi, we already did this by crushing the red light. When it came out here, it's white. It's white, white, white. Well, white is a lot more powerful than red. And then it just quickly settles down to its redness. I've got pictures showing chaos coming out here, absolute chaos. It comes from white and yellow and red and then all of a sudden it starts spinning down to these. They are just slowing down. It's all it is. They came through here high speed, they're slowing down. When they first concuss, they're just so powerful that they just boom. And the white, I will show you the white explodes and the black does not. That is what I have always had trouble with, was how these electrons can be in the field around it, hold on, and still, you see, they have a power. You remember the black spot before I showed you these here in the actual pictures of the light, and one of them was black, one of them, well, it was like this. Now, what I say is that one has power, that one does not. I say this is 1 electron volt plus, and that's 1 electron volt minus. However, the 1 electron volt minus can go through the roof. Hold on. All right, here we are. When these come through here, and I'm going to show you this picture right in a second, I'm going to explain it to here. It's accelerated, the pulse red laser. There's the Venturi. You won't see it in this one, but it's there. It's just so chaotic there, you can't see it. There's 2 metal pins here, just like drums. It's like 2 metal drums like that. And they're not that big. They're very small, actually. They're about the size of a nail. And that light is focused directly through the center of that. Now, remember, I said there's a dot there so small, you're never going to see it. It's just like you had this right here. All right, and the center of this, get the dust off of it. The center of this, there's a dot you're never going to be able to see, but it's in there, and that dot has some interaction to a distance, which I will call a magnetic field that keeps everybody else away. So another one comes along, and it hits it, and when it hits it, it could just go pop and bounce away and just have a nice time and just sort of drift along and do this and that. But if it slams into it, they are gonna explode. I mean, you could feel it when you push. They're weak now. You push like that, you can't hardly make them. It's obvious. Everybody understands that. So that's just basic explosion technology. There's no big deal there. And then they found, this is the crazy thing. They found somewhere out in space, and they said, "Oh, we found a gravity wave." Well, what happened was two gigantic planets or stars or whatever collapsed together and hit, and they created just a gigantic bang. Well, it's not going to go out into a point. It's going to come out in a round ball around them. They see that ball coming. They say, "Oh, it's a gravity wave." No, it's not. It's an explosion just took place somewhere, and all this stuff is coming at you. And it's not coming at you in one dot. It's coming at you in a curved manner because it's basically that ball coming at you. Virtually everything that they come up with is just honestly, it's nonsense. Total nonsense. When you hear how easy gravity is, they never can figure gravity out. It's just unbelievable. Gravity is so simple, a 2-year-old can figure it out. I'll show you in less than 1 minute if you can't figure gravity out. Hold on. Well, I got ahead of myself. We'll go back to the gravity, don't worry. But here is what is called gauge bosons. You see these little black dots? See, what are they doing there? Not a single black dot here. Not even the tiniest hint of blackness. They are all here, and they still retain that exact signature of that round black dot. Remember, I showed you before in the light pictures. There was photons. That's the carrier. That cannot change voltage in my world. That's as strong as it gets. It's got 1 volt. I'll give it 1 volt. Hold on, I got something around here. Here's what we're going to do with this, because you can see it right there. That's the plasma. There's the gauge bosons. These are what they call fermion. There's a whole. I don't think they understand it at all, to be perfectly honest with you. But this is what I would call a weak atomic force. It's a charged particle carrier. It is not charged itself. It is a charged particle carrier. I believe its potential voltage is 1 volt plus. It's a positive 1 electron volt. The white ones, when they're originally attached to these, are a negative 1 electron volt. However, the negative 1 electron volts can just go out through the roof. If you smash them, they will explode. These, I don't know whether they're just so hard they won't smash, or I don't know why they keep the exact same structure and look to them. I don't know. And I can see that they are not affected by each other. You see how close they can get to each other? They don't bother them. They're okay. Otherwise, they should be pushing each other apart. That's why these are exploding white. Now, here's the basic deal, and then we're going to go into gravity, which is, it's just, all it is attractive force to electrons. When you hear how simple it is, it's amazing. Now, so this is my energetics reactions treatise, a study of energetic reactions. And that's all there is energetic reactions. Now, what are they? We have electrons only universe. That means there's nothing more than these electrons. And those electrons just keep adding together until they make up elements. And in between every element, there's thousands and thousands of these particles, which are electrons. Now, you take 2 of these back like this, we call that a photon. The power one, I'm going to call it a fermion. There's so many different crazy words. I'm going to call that the fermion portion of this boson. This is the gauge portion of the boson. The gauge is just, come with me, red guy, and I'll let you go explode somewhere. And I will just sit on the sidelines. They do nothing other than carry the fermion, which is at rest 1 negative electron volt. And this doesn't matter where you are with this baby. It never goes out anywhere. Difference is 1 positive electron volt. So no matter what happens to this fermion, eventually it will settle back down to add back to the gauge boson, because it cannot stand on its own. When it's like this, it's trying to get back to these black guys. It's just insane here. They cannot stand there by themselves. You know, this is hard to, they can't stand in this explosive nature by themselves. They will stand by themselves attached to other molecules that don't want them there as part of their structure. They will let them just attach magnetically. And then what will happen is, if it's dry in the air, when you walk through it, you are a moist person. You get moisture. You have moisture on you. And you will attract electrons from dry air, because the dry air says, I don't want you guys around here. You electrons, go away, get out of here. I'm too dry. So go find a guy with some water molecules. And so here comes a guy right now. He's almost, it's like 90% water. Oh, jump on him. So they jump on you. And then what happens? You go touch a water pipe, and it says, whoa, the Earth will take him even better than this guy. Bam! Right to Earth. That is called gravity of electrons. We call it static electricity. It's static, floating in the air. It locks on you. Boom! It discharges to Earth. Now, what does that tell you? It tells me that the Earth wants electrons. It will accept electrons. It's called the Earth ground. I did a lot of electronics, and I understand it intimately. You ground everything so that if electricity gets loose within the system you're working on, it won't get you. It will go through the chassis and so forth into what they call Earth ground. Now, lightning does what? Pew, straight to ground. And when it hits the ground, it hits hard and it burns it. Why does it do that? Because all it is electrons. That's all it is. Same thing with static. You see it, snap. You see that light up, bang. That's all that is electrons. When you take electricity from a cord, the sparks are flying. That's all it is electrons. Now, what about when you take something like this? All right, there's a ton of electrons in here, but they are fused together with whatever is in here. Now, whatever is in here, where is it in this? How many electrons does it have? If it's down here, you drop it and it just barely goes down. If it's up here, you drop it and it smashes through the table. Why? Because there's more electrons in the same package. The more electrons in the same physical package, the harder it hits the Earth. It's as simple as that. If you have less electrons in this, it will hit less hard. If you have only hydrogen and helium, they don't have enough electrons to go down. They go up, and they go way up, because they don't have enough electricity, enough minus charges to come to the Earth, electrons. You have to have a certain number of electrons to be sucked down to Earth. Now, why does the Earth suck electrons? Why? Come on. Well, the Earth sucks electrons because it is a generator. You say, "Oh, Roger, I never knew the Earth was a generator." Well, that's because you didn't pay attention to what is going on in outer space. Because you listened to Mr. Einstein and all those people who I am almost 100% certain all of those guys were plants by the, whatever they called it back then, the CIA, to make nobody understand the reality of physics. They put him up as a, he's sticking out his tongue at everybody and flapping his ears and all that business. And he was just a buffoon, really. I mean, when you look at it, they all were. You cannot even understand gravity with the way they were thinking. It's just insanity. They were put there to destroy science, not to promote science. They destroyed it. And that was, I'm almost certain that was government. And they're still doing the same stuff. Because nobody can be this inept. Nobody, it's impossible for anybody to be this inept as we have right now in science. It just can't, it's impossible. Now, there's some people that are doing very specific work. And they're doing good work because they're working with molecules and they're exciting them and they're getting light out of them and all that. I like that stuff. Now, there's a lot of stuff they're doing I do not like whatsoever, and they will end up paying the price for that. I guarantee you. This messing around with all the, DNA and all that, no. Oh, very, very bad. Way bad. Now, so let's get back to what we can talk about that I have any control over and still have no control over, but I'll still talk about it. Now, I said there's the fermion, 1 minus volt, there's a gauge boson, 1 plus volt, half of this is an electron, and there's an up and a down. I'm good with that. Now, only the fermions have the charged explosive nature, and that's what I'm calling the charged particle, the fermion. Now, the gauge bosons, they're strictly carriers. They have nothing else to contribute. Now, light is a spinning particle. So when it spins, like this, right-hand spin, fast as hell, it looks like a wave from the side. If you see that, it's a wave. You look at it from the side, it's a wave. But no, you look at it from the front, it's spinning at you. And I could prove this, and not making nothing there I can't prove. Everything here I can prove, basically. I mean, I can't really get down to the point of proving that protons are this size and so forth. But I'm in my mind, it's proven. Now, because nothing can work with this gigantic protons, gigantic neutrons. They know this now. They're admitting it. The Royal Academy, Royal Institution of London, where Mendeleev stood on that same stage. Oh, this stuff is true. Well, it's not true, and none of it's true. And now they're standing on the same stage saying, boy, we really screwed up. And they're admitting it. Well, they can't do anything but admit it. There's something called lepton universality, which leptons are these little bitty particles. And there's supposed to be, I'm not going to go through all that business, but there's only supposed to be a handful of them. Well, then they found all these tons of them. Well, obviously, because they're coming out of big chunks of this and that when they slam them together. Man, anyway. So, elements are the stable numbers of electrons. Isotopes are just the unstable numbers. They got a couple extra ones hanging off of there, or they don't have enough. Now, this is called Mudfossil electron flood theory. Now, what we are going to do is I'm going to show you all of these things one at a time. Like I said, this is going to take some time. If you're interested, stay with me. If you're not, well, that's good for you. But if you want to know how gravity works, stick around. Okay, I know I said something about, messing around with DNA is going to really, that's a real problem. I look at DNA for all my mud fossils, but I do not alter it. That's the difference. All right, I am going to tell you, this is nuclear structure right here. This is the core structure. This is brush pulp. Now watch this. If you want to find the secrets, talk to Tesla. It's all about vibration. And that's exactly right. It's the frequency, the vibration, and it locks in an energy level. Here we go. Now let's just come out to where they start shaking the table here. Now what they have is a table, and they have an oscillator that's going to oscillate that table and shake it. Zzz, and they have salt on the table. Now salt is a polar molecule, NaCl. You got the Na way over here, you got the Cl way over here, you got a positive, negative particle. Now, let's see what happens when they do this shaking. Alright, so it's a tone generator. The pitch of the tone increases. Okay, so they start real low. What are we going to see? Now, I guess I'll turn it up a smidge. I don't know if you hear now. Well, they just got music. Okay, now, what are we looking at here? That's the central core. I am saying that is this. Now, around that, you are going to have electrons. You are going to have more out here that want to get in, and they're not allowed. So they hang out in here. Now, normally you only have two. This is called the s orbital. And you could have two here or two there. That's basically the way it seems to be. Now, then we go up into the next orbital. Then you get into what's called the rule of 8. Now watch what happens here. Boom! And it locks in. See? 1033. Now, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8. That's the rule of 8. There's your core. Now, from the Bohr model, they had, it's a certain number of electrons here and a certain number of electrons there and a rule of 8 and all this business. Well, we know that the whole entire Bohr model is wrong. Now, that part doesn't seem to be all that wrong. Well, let me put it this way. The nucleus, subatomic, was wrong. There is no question about that. Now, this, I feel, is like every one of these is one of these. Right down in the center of that. Wow, it's stuck. Anyway, this is so cool. And it says, don't come close to me. You come over here, I'm going to push you back. I'm going to push you back. Wow, that's amazing. Anyway, and it goes up. It just keeps going up and up. I have to remember that. Now, and it goes up to the next frequency, the next frequency. So, I don't know. There might be thousands of particles out here. I have no clue. Excuse me. But it keeps getting more and more and more complex as you get more and more and more particles, as the frequency gets higher and higher and higher. And it starts making some really exotic looking stuff. You see that? Look at this. Here you're up at 5284 frequency, and now you're going to go up even higher than that, I think, maybe. I got 6051. But you see, excuse me, 1, 2, 3, 4, 5, 6, 7, 8. You're still seeing these rules of 8, which is what they call the atomic rule of 8. So I'm going to stick with this for now. Okay, now you've seen the electron showers that I showed, and I say they are neutrinos. And you say, well, what is that all about? And I say, well, let's look into what a neutrino is. It's a fermion, which I said was the power part is the fermion. The other part is just the gauge boson, the carrier. No. So it has a certain spin. They say it interacts only with the weak subatomic force and gravity. I'm okay with that. Because gravity is nothing more than magnetism. Weak subatomic force is within the core. I'm okay with that. Now, the neutrino is so named because it's electrically neutral and because its rest mass is so small that it was long thought to be zero. It is the singlest smallest particle there is. And that is what I'm showing you. That's what I work with, is the smallest ones, not the ones like CERN. But they're trying to find the ones I'm working with there. It's crazy. The mass of the neutrino is much smaller than that of the other known elementary particles, which are like protons and neutrons, because they don't exist. The weak force has a very short range. Remember this one? The gauge boson? Very short range. It just holds on to that one. No charge whatsoever. Very short range. Remember this. This is a neutrino. It's the mass of the neutrino much smaller than that of any other known elementary particle. The weak force, very short range. The weak one is the black one. The gravitational interaction, extremely weak. It's only one single electron. And neutrinos do not participate in the strong interaction. The strong interaction happens there. They're calling this a neutrino. I call this the gauge boson, but I can call it a neutrino, call it anything you want. So the neutrinos do not participate in a strong interaction. That is the one, I called it a fermion, and that does participate. Thus, neutrinos typically pass through normal matter unimpeded and undetected. No, they pass through normal matter and jump right back to electrons. They are not independent particles. They want to be attached to electrons. The only way they will separate from an electron is under extreme duress. Now, what else do we have here? Weak interactions. Well, what is that all about? Weak interactions create neutrinos in one of three flavors: electron neutrinos, muon neutrinos, tau neutrinos. I have the electron neutrinos. So I'm working with electrons, and I have the electron showers, the electron neutrinos. I showed you that. Then they have bigger ones, muon neutrinos, tau neutrinos, and associated with the corresponding charged leptons. So they may even call the electron neutrinos red, muon green, tau blue. I don't know. But they're different size neutrinos. They say there's three flavors. This is maybe what they're talking about. I don't know. And in associated with the corresponding charged lepton. Now, although neutrinos were long believed to be massless, they're not massless. That's what Einstein said. Oh, they have no mass. All these things have no mass. And they always believed this stuff. I'm telling you, he was a CIA plant to make people not understand science so that they could make bombs to go kill people and nobody would know about it. All right, so it was long thought to be massless, but now it is now known that there is three discrete neutrino masses with three tiny values. That's exactly what I have found. And I'm going to show you these. I could show you the red and the green coming through the same venturi at the same time and two different powers. Now, a neutrino created with a specific flavor has associated specific quantum superposition of all three mass states. As a result, neutrinos oscillate between different flavors in flight. Well, I've seen them go different flavors, yes, but that's not the norm. There's three different flavors amongst them because they, once you're spitting out particles, you can't just say, I only want the one particle. You're going to get 1s, 2s, and 3s, absolutely every time. You can't separate those out. All three mass states. As a result, neutrinos oscillate between different flavors in flight. Well, they don't oscillate. They have three different flavors. Now, for example, an electron neutrino produced in a beta decay reaction may interact in a distant detector as a muon or a tau neutrino. Well, in a distant reactor, yeah, because maybe it's slowing down. Although only differences between squares of the three mass values are known as of 2019. Well, this is 2020. Cosmological observations imply that the sum of the three masses must be less than 1/millionth that of the electron. Well, I don't know about that. Where did they come up with the sum of the three masses, 1/millionth that of the electron? No, it's not. It's the same as an electron. For each neutrino, there also exists a corresponding antiparticle. And I have found those, but they don't always exist. No, that is not right. Which also has a spin and no electric charge. Now they get into nonsense, because everything here after this is assumptions. Once they start, well, it has to do this and it has to do that, and one reason, if you have that, you obviously have to have this, and the spin has that, and polio, blah, 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 blah. Well, not a word they have said has come to pass as being correct. So let's take a look at some of these assumptions and statements. Don't forget now, we saw the electron neutrino showers. We're using light. They were electrons. They were showers. They were polar fields. We saw the Cherenkov white plasma. Now, these other neutrinos, I don't know. Maybe they're there, maybe they're not. We're looking at the smallest one. And then beyond that, we got smaller. Now, they talked about an antiparticle. There's always, for this particle, there's always an antiparticle. That is not correct. These particles are normal particles. They spin to the right. An antiparticle spins to the left, going this direction. If you're spinning to the left, going this direction, you are sucking power into yourself. If you're spinning to the right, going that direction, you're flipping the particles out around, creating these Higgs fields, which are these polar fields. And you can see the particles. And I'll show you one better than that. But what happened here was this is all the particles coming at us. These are the little zip, 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 and then they slam into the static, ether, which is nothing more than static particles just laying around having a good time, and they go flying. That one is a reverse spinner. It sucked power into itself. Then it concussed with one of these. And at that point, we got interesting reaction. You see that? That's that little white particle. Now, it came down here and it hit this, or hit the field that it was going to interact with, and it siphoned off that, which appears to be like a mini disk of this. Now, if this is from red laser, which is the lowest form of light, red is your bottom color, and then you get that, explain that to me, Lucy. I don't have any clue. All I know is it came through, pow, and it did that. And you do not have an antiparticle for every particle. That's just not true. All right, now, as to the claim that light is a wave, it is not a wave. It spins just like this. And when it spins, this is through the venturi. All right, the venturi is here. It's a single slit. It's not two slits. So it's blocked off like this. We're spinning, and it's coming through this blockade, and down in the back there's this plate, and the light is shining on that. So it's going this way. As it comes over the top, it comes over that way. Some light goes over this way, comes over this way, and some's hitting this way, some's hitting this way, and it's going over here. And these are where you pick up these, what they call interference patterns. They're not interference patterns. Those are actually repulsion patterns. As that light comes through the accelerator, those particles do not want to be together. So they end up creating stripes, one right after the other. But they keep, everybody stay that way, you stay this way. So they get a line, a line, a line, a line. That's why you get these. That's all that is. All right, so obviously you know that the light is a particle. Light spins, light accelerates, light has mass. We saw the gauge bosons, which are the particle carriers. They are not powered. They just have enough power to carry that other particle. That other particle is a hand grenade. When it gets to where it's going, it just goes off like a bomb. Depends on how hard you hit something else, how much brightness comes up. And how hard you hit something depends on how fast the particle was ejected. All right, over the course of time, it's going to slow down. If you shoot it out through the air, it's going to sort of, because it's coming through a big field like this. It's sort of getting nibbled down as it goes out, and eventually it just sort of evaporates into nothing. Now, I'm going to show you blue laser through glass. Let me show you some of that. So you see it spinning here. Now let's see what it does when it hits a medium that partially allows it. This is very cool. All right, don't forget now, this is what happens when laser just comes through the air. All these little white particles all over the place, those are particles that are being concussed. Because as this particle comes through, and it's only the particle right there, there's a dot right there, a particle you can never see. But it owns that big region around it. So as it comes through, everybody's getting concussed. That's why they're glowing. But it's not going to do any more than this. It's not going to turn into a single dot or anything. But let's see what happens when it goes through glass. Okay, my friends, this is light going through glass. Now, if you look, you can see a border almost here and over here, where it's really concussing and it's sort of limiting it to how much it can really spread out, because it's within the glass. If it was just within the air, you'd have that nice big wave, but now it's sort of restricted, and you have a lump. You see the lump looking thing? Now, that is through glass, and I might have said somewhere during this presentation that the particles were all different sizes, the red, blue, and the green, red, green, blue. Now, I don't think that's I don't think that's true, and I just came to that realization a few minutes ago, because I can see they travel different distances, but they are still the same particle, identical same particle. They say they are a tiny, tiny little different weight. Well, I'm not saying it's not impossible, but I'm saying that I'm seeing the same particle and I'm seeing them do exactly the same thing. They look exactly the same way. The only difference is one travels further than the other. Are they higher speed? At the end, I said something about a 22 long and a short and a long rifle. It's like three different speeds, the same particle. Now, if that's true, and I think now it is true, it changes things. I mean, I got a lot of thinking to do. I got to be honest with you, I got a lot of thinking to do about this. But the light part, that's not a big deal, because it's just three different colors, that's all. Now, once you get into the big chunks, nuclear radiation, ultraviolet, X-rays, all that stuff, well, that's a different story. Same thing with cosmic radiation. That we really got to look into a little closer, but I just think they're bigger particles. They're just bigger chunks. It's like when you excite this and one of them goes shooting off, it's light. When two of them or five of them go shooting off, it's X-rays. And when 50 of them go shooting off, it's nuclear radiation, and you get hit a couple times, you die. I mean, they're just bigger and bigger, bigger chunks, as far as I can tell. So, anyway, I just made that point. All right, this is pretty obvious. That's the particle coming at us. It's just spinning like crazy. Now, that's the spark particle at first concussion, less. Now, what are these dot, 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 dot? That's as it comes through here. It's like zzz. So all of these guys are being thrown out like particles around as a shell around. And you can see again the concussion of all the other particles that exist in the air that are glow when they are getting concussed. All right, this is pretty obvious. This is just after the accelerator. The accelerator is back here just a smidge, and then it comes down here, and then you get this kind of a look to the particle. And then you get this look, then you get this look, and then it goes down to this, and it just sort of tapers off. Now, what is this look and what's that look? This is coming through at a higher speed. You can see it's more white. As it concusses here, the first place we can see it concussing, you see that spike and that spike? It's doing that. It's banging into the atmosphere, and it's just spiking itself up. I don't know if you can see that or not. I hope you can. See it? Isn't that something? Now, that one over there, it starts to lose that spike, because it's now, it's slammed, and now it's sort of working its way back out, and it lost the spike. And then it goes further here, and it just turns back into a Oreo cookie. All right, now this is the green. You see, way back here is the accelerator. This is a whole different distance way out. Same looking particle. That's what's sort of throwing me for a loop. It looks like the same particle, and the same thing. You see the spikes, and then it sort of gets blurry going off. And when it first comes out, it's just sort of a little, I don't know what you'd call it, a little two-piecer, and then it turns into that. And that happens at quite a bit distance further than normal, because I had another guy here, Fabian did this, Fabian Boulaire, over in France. That's the red. That's the green. Same Venturi. So you can see, obviously, the red has a whole different impact than the green. Now, they are the same looking particles once they settle down. They settle down into the same looking particles. But they say there's three of them, and they're just a smidge different weights. Now, I got to think about that, how that would orient itself coming through the Venturi if they were two pieces at a time instead of one. Why would they do that? Why wouldn't they come out as one piece at a time? Very hard to figure that out. Okay, my friends, like I said, this is going to go extremely long, so if you're in it for the long haul, I want to explain some other things that people don't understand, such as boiling water. Well, what is boiling water? Boiling water, and you see all the little bubbles rise up when you turn your heater on and the pot warms up and you hear it going, and the next thing you know, bubbles are going. All you're doing is forcing electrons, which are those big bubbles, to invade that water. Well, what happens at first? Remember I talked about ether? Ether is everywhere. And you can have a bunch of ether, but it will start accepting it because as heat, it will say, come on, okay, electrons, you're all right, you can come in here. But, you know, oh, whoa, you're getting too many. And then it starts to get warmer, and then it starts to, and then it says, whoa, this is it. You got to stay out of here. And he says, oh, we're coming in. And then your molecules start to expand, and your bubbles start to form, and then you get heat, and then all that heat is trying to get out of there because other areas will suck it in. But you're forcing it in so fast that it can't get out fast enough. That's how you create boiling water. Because you could put the same amount of things eventually into that water and it never boils. You have to put them in fast enough so that they can't escape fast enough. Now, so that we're talking, that's boiling water. Okay, so bingo, done. Now, we talked about the 21 centimeter rule, which is around particles, a huge distance that they control, done. Salt vibration, we looked into that, which is the nuclear geometry, it looks like to me. We looked into the rule of 8. We did we do the magnetic field? No, we didn't, because that also is your gravity. We're going to talk about that uno momento. Ether we went over. Neutrinos we talked about, and neutrinos, the black part of the neutrino, which is the gauge boson, is never meant to be alone. So I don't care if they go 10,000 meters into the earth to try to find one coming all by itself. It should never show there because it's always going to find an electron. There's always electrons waiting for those things. So they're never going to find a gauge boson, which is what they call an electron neutrino, the weak one. Anyway, that's done. Ether, we talked about neutrinos, got a bing, done. Now, sun's corona, let's talk about that. Okay, here we are looking at the sun behind the moon. So, what does that mean? It's a solar eclipse. All right, so the moon is, for all practical effect, fairly dark. Behind it, though, the sun literally is the same diameter, only we can see it now. We're not seeing all that stuff coming at us. So what do we see? Well, what do you see here? And what do you see there? That's the polar axis of the sun. That's the polar axis. And what do you see here? And what do you see here? Well, it's obviously spinning through space. And this is coming around it. Or it may just be going this way. But I understand generators and I understand electronics. I worked on these things. I rebuilt them for General Electric. I understand them very well. What we have is a field around here. And you say, well, what is that field, Roger? That field, all out there is the particles that have been emitted from the sun that it has to pass back through again, and from all other luminous sources in the universe. The entire universe is filled with electrons, which are the particles from the sun. Now, they say, oh, what is solar wind? Well, yes, the solar wind is the bigger particles. Those are the, atoms and little tiny molecules and things like that, and chunks of particles, bigger particles, cosmic radiation, all that stuff. Yes, absolutely. But the things you do not see are the light. You don't see the light. It's got the same power. I mean, they're not the same power as the bigger particles, but it's got that same concussion. If you hit those, you're concussing them. So Hubble had to go with the nonsense that Einstein said, the light never slows down. Well, it's crazy. So Hubble says, well, everything's speeding away from us because the light never slows down, and we've seen everything that redshifted, so that means the only way it can redshift is to either slow down or go faster. So it's got to be going faster. No, it's slowing down. Here's another crazy thing. This is absolute insanity. Einstein, 1918, I think it was 1918, 1919, something like that. He says, well, if the sun is... I forget how he even figured out how he... In other words, he said gravity, space-time, or some warp, or some bullshit. The particle from behind the sun was seen in front of the sun, a star. So obviously it wrapped around here. Well, of course it does. But it wasn't necessarily 100% related to the gravity of the sun. It could very easily have been related to what they call a thermodynamic effect of this thermal layering. Just like when you look at a, what do you call those things in the desert? I can't even think of it. You know, the waves go in a desert. A mirage. So you're looking out, you see a mirage. Well, this thing's up here, but it's actually down here somewhere. Or it's up here and it's really down here. Same thing with what Einstein did. I don't think they took into any account about the thermal radiation that sits around the sun. He was a CIA plant, I'm telling you. You can make anybody think anything if you think the guy's a genius. You say, well, the guy's a PhD. To me, that means don't listen to a word he says. I'm serious. You might as well forget it. The only way you can work with a PhD is if you say, all right, show me what you made. If they make something, God bless them. If they start talking about this and that, about theory, you might as well turn around and walk away because you're just wasting your old time. Now, I can see there's all kinds of particles coming out of the sun. And I can see the sun's axis is here. And I understand the sun is rotating, and that's why we see this magnetic field, and it's scrubbing its particles, which it has in its envelope that surrounds it. Those are nothing more than particles that are nothing more than molecules that are nothing more than electron-coated atoms. Everything is coated with electrons. So what happens? These are all electrons just laying around out here. This is coming, scrubbing through them. That's a generator, because nobody's powering that thing. It's spinning by itself, but it's spinning against the electrons that are out here. So what does that do? It creates a magnetic field. And what it does is it makes this go around and come back around this way. It makes this, because it's spinning, and there's a right-hand rule. You go this way. Spins this way, go that way. It's going up this way, it comes back around. And this is what happens. It's throwing those electrons through this way. Out here, it's millions of degrees where it's scrubbing through the atmosphere. Down at the sun's surface, 6,000 degrees. Millions. No other reason possible. Absolutely none. And not only that, on our Earth, just assume that's our Earth, have the identical same situation. We are spinning through the soup that's in front of us. Now, not only that, we got issues, serious issues, because this is a generator, just like I said. Let's say this is the Earth. We know we're spinning, we know we're going around the solar system, and we know we're being ripped through the galaxy on the arm of the Milky Way. All of that stuff forces all of this stuff against us. We are crushing into it, crushing. Electrons crushing. They are collecting on our Earth. They have overheated our oceans. They have overheated the entire Earth. They have overheated the skies. They have overheated the buildings and the trees and the cars. They have overheated the atmosphere, and they are not leaving in the amounts that they are coming in. We are adding to them with every molecule we split. Carbon dioxide, basically. You know, your hydrocarbons, when you start burning them up, you're spitting out electrons. It has nothing to do with the C and the O. It has to do with the electron release. The electrons are these things. They were stuck inside of little particles like this. Once they get out, they're like this. So now they're banging into everybody all over the place. That's the problem. You've got too many extra electrons in the atmosphere. And it's creating unbelievable weather events. Australia, this is that fire and all that stuff. I know they say, oh, they let it dry out too long, and it's just one of those things. No, it's not. In my world, no. Maybe I'm wrong. Maybe I'm wrong. But, well, let me just show you something that somebody just sent me about Australia. Okay, you know how all of these kind of crazy weather things are going on all over the place. I just got somebody from Alaska sent me something. He's saying the weather up here, I think he's up around Nome, not Nome, but he's way up there in Alaska. And he says it's raining outside. It's warmer than it's ever been. It's crazy. There's all kinds of, Prudhoe Bay, I think he was at. And I have friends all over the world, and they're telling me things that have never been the way they are right now. And look at this. This is Australia. Now, you know what happened there with the fires. This is, I'm not sure where this is in Australia, but it's in Australia. And this, I guess just happened now, today. Anyway, it's things are a little different than they have been, and they're not going to resume normality, I don't think. And the reason is, I don't think we are going to be able to discharge the electrons that we have that have accumulated in the atmosphere, and in the ground, and in the air, and in the water, and in the buildings, and the cars, and the people, and the roads, and the trees. Every single thing has been, once heat is heat, that's extra electrons. That's what heat is. It's extra electrons that don't want to be there. They want to go somewhere else, but they can't find a cold place to go to. They tried to find it, and they found it up in the Arctic areas, but they've taken on more than they want for the way they work in space. And I want to tell you something about space. Now we're going to get into the gravity and how we are in space. And I know this is always an issue. All right, now let me get my globe. Okay, if you want to know if the Earth is round, all you have to do is look to the North Star from above the equator. If you're below the equator, you cannot see the North Star because the Earth is round. Now, you'll still thumb me down. Anyway, what we are doing is scrubbing through space, which is out here with all tons of electrons. As we scrub through it, we are creating electrical push. Not only that, I want to show you another thing, because I believe the pole could quite likely shift and flip. And the reason is because we are pushing harder and harder and harder. The more we build up energy here, which we are, building, it's pushing. That means the pole keeps going where it shouldn't go. Now, it may at some point just decide to flip around. I don't think the Earth is going to go tumbling or anything like that, but I don't know. We're not looking at these things in the correct manner, I don't think, to make that decision. Okay, there's our solar system, and there is our sun spinning this way, scrubbing, and particles are being ripped off because it's spinning this way as the atmosphere is coming against it. And there is a ton of atmosphere out there. We don't see it. It doesn't look like anything, but it's basically these tiniest particles that they always thought had no mass whatsoever. They are light particles. Now, what else has happened? All of us are spinning around it, all the planets, Not only are we spinning around and forcing ourselves through all that stuff, but at the same time, the planet is spinning around every day, once a day it spins. Now, so we're spinning once a day, we're spinning every 365 days around there, and we're going through this way through the Milky Way, ripped through the arm of the Milky Way. Now, are we getting into denser space? Maybe, maybe not. Okay, that is the way the galaxy goes. Now, our solar system is doing all that other stuff as it's going through there. Now, are we going to cross paths with one of these, or are we going to just go into an open space? If we went into an open space, that would be nice, because then we wouldn't have so much impact. If we hit one of these, we're screwed. Now, what is gravity? Here it is right here. Simple as this. It's just absolutely so simple. It's amazing. These are electrons all over here as we are crushing ourselves through as we are spinning. That creates a generator. A generator creates a magnetic field which sucks electrons up through our pole from the south to the north, the right-hand rule, around and around, around and around, and they pull down from the surface of the Earth as well to go up through there. Now, obviously, the things like this on the surface hit the surface. They don't go down in, but electrons can flow into the Earth. That's what electricity does. It's called earth grounding. Okay? That is gravity. It's as simple as that. The bigger the planet, the harder it scrubs, the more electricity it creates, the more magnetism it pulls. It's as basic as that. And the way gravity works, I don't know, I probably went through this already, but I'm going to go through it again, because I can't remember it. To be honest with you, this is one of the longest videos I've ever done. Now, all of these particles are being pulled into the Earth and moving north, and I think the Earth could be hollow. I see no reason it wouldn't be hollow, because I've seen what happens in space when they spin, and I'm going to show you because it's very cool. Now, the aurora borealis is up here, and you see these little lights coming down and twinkling around these lines up here, and these lines down here, the northern and the southern lights. Why is that? Well, the light is hitting on these lines coming in, and it's interacting with them, boom, 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 like this. Those are the things that are shooting out. These are the things that are shooting in, and they come down as veils of colors. Those are the northern lights, the aurora borealis. And I guess they call the aurora australis or something like that. Now, let's look at the outer space water spinning and what it means for hollow Earth. Admiral Byrd said it was hollow. He said he was inside the Earth. I don't think he's a liar. Okay. He's going to rotate this water in microgravity. This is plasma Ben, and this is on the space station, and what he is going to do is rotate that ball of water, and he's got some little surfactants in there and some stuff. He'll explain it. Now, what do you think will happen to that ball of water just floating around in space? Because we're nothing more than a ball of water floating around in space. And I can tell you what, right now, the Russians drilled the deepest hole on the face of the planet. Look it up, Kola Deep Borehole, Kola. One of the huge surprises was the deepest part was saturated with water. Now let's watch what happens to something that's saturated with water when it spins in space.
Here we have a rotating sphere of water about 25 millimeters in diameter, and inside this sphere are a whole bunch of little tiny air bubbles. And we will see what the angular acceleration due to rotation does to these air bubbles as a function of time.
Obviously we are rotating. Obviously we are in space.
What you are observing are the bubbles moving to the center axis of rotation. as a function of time, they will form this rather tightly packed bubble core. These bubbles are kept from coalescing from a small amount of added surfactant to the water.
In other words, what he's saying is they would coalesce into just a tube of nothingness in there.
Here we have a rotating sphere filled with bubbles and tea leaves, and as expected, the bubbles go to the center and the tea leaves go to the outside edge, along with a few chunks of orange peel.
That looks like Earth to me. Now, they say that at the poles, there's holes. There's holes at the poles. You look up Byrd. Look up Admiral Byrd. He went inside the pole. He met the people in there. That's what he said. And his whole team recorded the same thing. And I went up, and you look on Google Earth, go right over the top of the South Pole. Put in South Pole Google Earth and click it. When you go over, there's a white dot there. And when you come into it, you'll see rays coming out of it like rays of the sun. It's because those are the rays of the magnetic poles. We're not being fully understanding of what, well, we're not understanding whatsoever about literally anything of our past, of our history, and literally of our future. And my future is getting pretty short. And so I want to understand, because there's going to be something after this. If there isn't, I am going to be thrilled, because I am worried as hell about what is after this, because I don't know, and you don't either. So don't anybody tell me anything. You know, I'm done with people telling me, oh, you got to listen, you got to listen. I do my own looking. I do my own thinking. Now, I do have a guy I'm going to be looking for when this is all over. And it's God's son. And if all of that's true, and I believe it's true now from everything I've tested and looked at, and, you know, I didn't just guess and hope for the best. You know, which, you know, you could, and that's fine. But, you know, I sort of went a little deeper, and I feel a lot better about it now. That, you know, I'm hoping I'm going to get out of this thing alive. I always said nobody gets out alive. Well, this time I think it's certainly a possibility. And if it goes down the way it's written, there's two places you end up, one or the other. And I want the other. The one doesn't sound good, the other sounds pretty nice. But there's a lot of obligations. You don't get nothing for nothing. Capiche? All right, here's the deal. If anybody's interested, all right, I am doing, again, it's all electron flood theory. I have a lot of information. You know, it goes beyond this, a lot beyond this. And same with our Earth, the corona of the sun basically proves we're scrubbing through. It's got 1 million degrees on the corona, 6,000 on the surface. It's insanity. Those magnetic loops that are flying out there are because they're magnetic interactions. At the end of those loops, they make a snap. And when they do, they shoot off particles into space. The particles coming from every luminous body we can no longer see in space, they have a mass. They have a potential. They are energy. They just are dark. They're matter, they're energy, and they're dark. You ever hear that? Dark matter, dark energy. That's all it is. It's a light that's been spit out into the atmosphere, into the space that is not concussing. When it hits you, and all it concusses, burns your skin and everything else. So we are obviously concussing through all these particles. And no way in the world can you scrub through those particles without collecting them. We have collected them past our ability to absorb them any longer. The Earth is extremely overcharged. I don't see any way out of it. I've been screaming about fusion, and I think the particle accelerator that I've been showing creating those Higgs bosons and splitting up all these little particles. We could do fusion. When it comes back together as as helium instead of heavy hydrogens. That leaves you about a 20% free energy. And this is passive. You don't have to have any extra energy really to speak of with this device I'm talking about. It would be fully self-sustaining and create tons of extra energy as far as I could determine. At a very, very reasonable way. You don't have to have 6 miles to go around in a circle and crash things head on. We're going to force them into each other. And when they do, they will turn into plasma just like I showed. They'll come out of the other side all in little bits and pieces. When they come back together, they say, come back in your most stable energy form. We put them in high energy. They had too many electrons, too high energy. They weren't normal hydrogen. They were heavy hydrogen. So as they add back together, they say, well, I don't need all that stuff. Let's become helium. It's okay, let's go do that. And they say, well, what are we going to do all this stuff? Well, we got to pull it out of there with an electrode or something like that. Create heat, let it go into some other medium that creates heat and take the heat out of it, however you want to do it. Somebody smarter than me has to do that. At this point, I'm pretty much off the case. What else am I going to do? I'm pretty much at the end of my rope on this now. But I would love to talk to somebody. It's Roger at mudfossils.com. All right, I love you all. God bless you. And pay attention. All right. Do not ignore things. Investigate. Think. Do not think just because someone read you a story that you have to believe it. Because if you do, you have been, they just got you. And you paid them to tell you these stories. And the stories are not true. Now, maybe if you figure, well, I bought them, I'm going to have to live with them. Well, that's maybe the truth, because you're never going to get it turned around unless you speak up. And I think there should be free education, or some way of getting this, our stuff is going to be free or very, very close to free, Mudfossil University. And it's the only place you're going to find the truth. You're listening to me? The only place on the planet that you will find anywhere near the semblance of truth. Anywhere even close. Anywhere with anybody that's willing to stand up and speak about truth. Mudfossil University, the only school on the planet right now that will address truth and is not afraid to speak about truth. All the other universities are shaking in their boots, and they should. They should have stepped up and said, nobody expected this, let's take a look. And they ran into the woods and threw rocks from the woods at me. Well, I've got my own rocks. They're called mud fossils. And when they told me to shut up, the mud fossils are speaking. God bless you all.